This video is going to talk about molar ratios. Let's define that. A molar ratio is the ratio of moles between any two substances in a balanced chemical equation. So this means that we're talking about a chemical reaction taking place, and we're going to compare the amounts of reactants and products as they go through a chemical reaction. Let's use this equation as an example, or this reaction. This would be nitrogen reacting with hydrogen to form ammonia. So first we have to balance the reaction. We'll leave hydrogens for last. There are 2 nitrogens on the reactant side and only 1 on the product side. So I'll put a big old 2 coefficient in front of NH3 to fix the nitrogen problem. Now, this is 2 NH3s. That 2 gets distributed for each of those elements. So that means I now also have 6 hydrogens. 2 times 3 is 6. So I only have 2 hydrogens on the reactant side. So to fix that, I'll put a big 3 coefficient in front of the H2 because 3 times 2 is 6. So I have 3 times 2 is 6 for hydrogen on the reactant side and 3 times 2, which is 6 on the product side. Now I have 2 nitrogens on the product side and 2 nitrogens on the reactant side, which means that we don't have to put anything here. But because we're looking at molar ratios, sometimes it's good to put the 1 there just to remind you that that is actually 1 mole. So if I were to add to the sentence that describes the reaction using molar ratios, I would say something like this. 1 mole of nitrogen reacts with 3 moles of hydrogen to form 2 moles of ammonia. So these are our molar ratios. Molar ratios are going to be those relationships that we use when we convert between one substance and another. If you remember dimensional analysis, we always started with a certain amount of something and had to use a relationship to convert between one thing and another. Something that's always true, like 1 foot is always 12 inches, for instance. So in these equations, we can make those relationships and we can compare any 2 things. Let's do nitrogen and ammonia. I can say that 1 mole of nitrogen equals 2 moles of ammonia. Notice that I'm just setting the 2 substances equal to each other and pulling down those coefficients and calling them moles. Another relationship I can make is between the 2 reactants themselves. I'm going to need 1 mole of nitrogen for every 3 moles of hydrogen. 1 mole of nitrogen equals 3 moles of hydrogen. Now, of course, they don't equal each other. They're not the same thing. But what we're saying is that these are the relationships of how things will react in the reaction. Finally, I can compare moles of hydrogen to moles of our product, ammonia. 3 moles of hydrogen equals 2 moles of ammonia. We won't do these yet, but later on we're going to use these relationships to convert between moles of one substance and another. Right now, your goal should be just to be able to recognize the relationship. So how about if you try this on your own? What is the molar ratio between C2H6 and CO2? Take a minute to answer this question. So we're looking at these 2 substances, and that means that we can ignore everything else. So I would say that 2 moles of C2H6 equals 4 moles of CO2. It's important to remember that these ratios are proportional, meaning that we're not always going to go into the lab and use 2 moles of C2H6. Maybe we want to use less or we would want to use more. Just like if you were baking or cooking, sometimes you might want to double a recipe. If that's the case, you have to, whatever you change about your recipe, you have to change about all of the ingredients proportionally, right? So let's look at this problem. What if instead of 2 moles of C2H6, we wanted to react 1 mole of C2H6? How would that translate into moles of CO2 that can be made? So there's a couple of ways that we can look at this. First, we can go laterally. We can say, let's highlight what we have here. Remember that if you're looking at 2 substances, you can ignore the other things. Okay, if I go laterally, let's look at those numbers. The ratio is 2 to 4. That means however many moles of C2H6 I am working with, I'm going to need twice that amount of CO2, or I'm going to make twice that amount of CO2, right? Because 2 times 2 equals 4. You can think, what did I have to do to that number 2 to get the number 4, right? So then what I would do is apply that to my problem. Well, if instead of working with C2H6 with 2 moles, I have 1 mole, well, I always know that the ratio is going to be the same. However many moles of C2H6 I have, I will need twice that amount, or I will make twice that amount of CO2. So 1 times 2 is 2. I'm just going to double. Another way that we could look at this is if we went and figured out what we did to our reactant and how that applies to our product. So instead of going laterally, we can go up and down. Well, I started with the equation telling me I need 2 moles of C2H4, but I'm just using 1. So what did I do to change the recipe? Well, I cut it in half because half of 2 is 1, right? And that's what I did to it. So that means I have to do the same thing to the amount of product I can make. That's going to be half as well. So half of 4 is 2. So it's important to remember that these things are always working in a proportional manner, and you can very easily make a prediction about using different amounts of substances in the lab, which happens really often. We usually don't use exactly what the recipe calls for. So try this one on your own. If we reacted 4 moles of C2H6 instead of 2, then how many moles of carbon dioxide would you expect to make then? So these are our 2 substances we'll focus on. Instead of 2 moles, I'm saying I want 4 moles. So what did I do? Well, in order to go from 2 to 4, I had to multiply that by 2, right? So if that's the case, I have to do the same thing on the other side and multiply this number by 2. So 4 times 2 is 8. 8 CO2s. Now, if you decided to go laterally, you could do that as well. I know that the relationship between my moles of C2H6 and CO2 is that I have to double however many moles of C2H6 I'm starting with. So that means I have to do the same thing here. If I'm starting with 4 moles of C2H6, I have to double that, and I would make 8 moles. 4 times 2 is 8. I'd be making 8 moles of CO2. Either way of solving that is appropriate. So in conclusion, molar ratios are the ratio of moles between any 2 substances in a balanced chemical equation. Those ratios are going to become the conversion factors for when we do dimensional analysis to convert between one substance and another. That is another lesson. Right now, just identify those relationships. And finally, understand that molar ratios are proportional. The chemical reaction will always react according to the ratios, regardless of your starting amounts.